Hi guys, welcome back to Symbolic Logic Part 20. So, under the method of deduction topic, we are gonna see some theorems and formulas which we will be applying in the upcoming problems. So, this is part 20. In part 19, we studied about the truth table and we have also solved some problems using the truth table. As you see and done, this truth table is very time consuming and complex. Because why we say it's complex? Because it's simple only, but when it comes to complexness, even if you make a small mistake, the entire sum will be error or wrong, so you will lose marks entirely. So that's what almost we will try to avoid solving the problems using truth table, even though it is easy to solve. Instead of that, we will be using some rules of inference in the upcoming problems to solve the problems and get our solutions quickly. So, as you seen before, in classical logic, we have seen about valid and invalid argument. So, in symbolic logic, also we have valid and invalid argument. So, as you know before, we say each premise as a proposition. So, the structure of a proposition, which we call it as argument, the structure of it is quantity plus subject plus quality plus predicate. So, as you saw the structure of proposition, the structure of proposition is what we call it as argument. So, the structure of an argument is in which order means, as you see in syllogism. If you take a syllogism, we already see the syllogism must have two premises and one conclusion. Like the same way, the structure of argument should be premise 1, premise 2, premise 3, and then the premise 4 must be the conclusion. This is the order of the structure in symbolic logic. So we also saw the what is the difference between valid and invalid argument in classical logic itself. In symbolic logic, we have a different definition, because this definition is based on truth table. When you see in classical logic, the definition is based on the proposition. As you see here, this is the definition which we saw in classical logic. Valid or invalid for deductive argument, and in inductive argument, less probable and more probable. So we are using only deductive argument in symbolic logic. So the case will be valid argument or invalid argument. So what is the difference between valid argument and invalid argument? So valid argument is it is in the form of one which has no substitution instance with true premises and false conclusion. That means the all the premises must be true and the conclusion will be false. This is not the case in valid argument. It is the case of invalid argument. So in invalid argument, the two all the premises should be true and the conclusion must be false. That's why we will derive it as, if that's the case, we will derive it as invalid argument. If it is not the case, then it is a valid argument. If you see, to be clear, in valid argument, the conclusion, premise and everything will be true. If you see the invalid argument, the premises will be true and the conclusion will be false. I hope this is clear than the before definition. So this is the common difference between valid argument and invalid argument. So when I mean by rules of inference, we have 9 rules of inference. So we will be seeing about the each rule of inference with the theorems to prove it is a valid argument. So the first one is the first one is, like, we have P implication Q, and the second premise we have P, and the third premise we have the conclusion as Q. So how we gonna prove it is, we will be conjunction the second premise and inference the third premise, which is a conclusion. So if we, as you seen before, if we make a truth table for this PQ, we have valid values, and P inference Q will be solving as we did before. Then the answer conclusion will be all true. So this, if the argument or a premise is in this form, we will be solving it like this, and this argument, what we call it as modus ponens, MP. So the second valid argument is P inference Q. negation q, therefore negation p. So this is the valid argument to do. So when we are so you will be adding, I mean, conjuncting the first premise and second premise, and implication the third premise. So when you do this, in truth table, in the conclusion we are getting all the values as true. So this is what we call it as modus ponens. So the next valid argument 3 years, p implication q implication r, therefore p implication r. So how you will be writing p implication q, conjunction q implication r, inference, sorry, not inference. So implication p implication r. So as I said before, we will be writing in the same manner, and we will be solving using the truth table values, and the conclusion, if you see, all the values are true. So this is what we call it as hypothetical syllogism. So if you see here, p implication q implication r, therefore p implication r. You can see the difference between each valid argument, right? So when it comes to the fourth valid argument, P, a disjunction Q, negation P, therefore Q. So how we will be writing it? So you will be writing it as P disjunction Q, conjunction negation P, and the whole thing implication Q. So we wrote like this, and while solving in the truth table, we got true values. So this is what this argument is, what we call it as disjunctive syllogism. So how to prove this fifth valid argument? Same as P implication Q, conjunction R implication yes, and again we will be conjuncting P disjunction R, and then finally the whole thing implication Q disjunction yes. As you see here, I have mentioned it. So this is what we call it as constructive syllogism. If you see, for every valid arguments, the conclusion will be true, whereas in invalid argument, the conclusion will be false. So argument 6 is P implication Q. Therefore P implication P conjunction Q. The same method, no need to confuse it. As usual, we will be writing on the solving the same method. So in the conclusion, we call the true values, and this valid argument we call it as absorption. So the seventh valid argument is P conjunction Q, therefore P. All these inference rules we must be mug up and remember it, so we can use it to prove the validity or invalidity of an argument. They will give an argument, and we need to prove whether the argument is valid or invalid using all these arguments. I mean, rules of inference. That's what we are saying, right? Rules of inference. So we are in seventh valid argument. So we have proved in the truth table. So the thing here is, what I want to teach here is, so P conjunction Q implication P. That's what we wrote, right? So P values, Q values, and next you will be conjuncting it P dot Q, and we got the values. And next what we will be doing is P dot Q implication P. While doing is, first we need to take T triple F values and implication P values. But many of us, what you guys will be doing, first you will be taking the T values and then P conjunction Q values. So what happens is, you will be taking like T T T F F F F F. So what will be coming is, automatically TF is false in implication. So this is the major mistake many students make. So what you must do is, we should not take uh, P implication P dot Q, P implication TF, F F F F, not that way. But how you should make is, first we need to take P dot Q, T triple F, and then implication, and the second thing is, we will be taking the P column, T T T. First P dot Q column, you should take the values implication P p column values, so that you will be getting t t t f t f f f f true. If you take the p dot p column first and the second column as p dot q, and if you make like t t t f f f f f t f will be automatically false, then you will be, it will be like this is not a valid argument, this is an invalid argument. So it will be like that. So this p dot q, therefore p is the, this argument is known as simplification. So the next valid argument is PQ, therefore P conjunction Q. In the same way, we will be solving it using the truth table, and we got all the values in the conclusion as true. So this valid, this is a valid argument, and this is what we call it as conjunction. No, last but not least, we have P, therefore P distinction Q. As usual, we will be solving as P and implication. We will be implicating the conclusion P distinction Q. And when we do the truth table and solve, we got all these things in our conclusion as true values. So we have known that this is a valid argument, and this valid argument is known as addition. So these are the nine implication rules which we need to use and remember to solve the other problems easily without using the truth table.